Welcome to our YouTube channel, Maths Point. In our today's video tutorial, we'll be focusing on triangles and we will see the different types of the triangles and then some properties related to the triangles. So let's first start with the definition of the triangle. And a triangle is defined as a simple three-sided closed plane figure. Or in other words, we can say a triangle is a three-sided polygon. That means it's a closed figure made of three line segments. Just like here, we are taking these three line segments and these three line segments are forming a closed figure. So this closed figure is known as triangle. So it is simply a closed figure made of three line segments. Now, the point of intersection of two sides, just like here, these two sides are meeting at this point. So this point is known as vertex. Similarly, there is another point where two sides are meeting and there is the third point where the two sides are meeting. So we can name them as A, B, and C. So we can simply say there are three vertices in a triangle. Similarly, the line segments that make the triangle, they are called sides of the triangle. So there are three sides in a triangle. Just like here, we are having the side AB, similarly side BC, and we have the third side as side AC. Also, the two sides meet at a point and form as an angle. So we are having three angles, just like here, angle B, angle A, and angle C. So there are three angles in a triangle. We can name them as angle A, angle B, and angle C. Thus, we can say in a triangle, there are three vertices, three sides, and three angles. So these are the elements of a triangle. Three vertices, three sides, and three angles. Now, let's see the different types of triangles, and these types of triangles are classified on the basis of first, lengths of the sides, since there are three sides in a triangle and they can be having different lengths or they can be having the same lengths, and on the basis of the lengths of its sides, triangles are classified into different types. Similarly, triangle is having measures, triangle is having different angles. There are three angles in a triangle, and we already saw in one of our tutorials that on the basis of the measure of angles, there are different types of the angles. So on the basis of measures of angles of a triangle, triangles are also classified into different types. Let's see the first one, that is types of angles based on lengths of its sides. And the types that we are having here are scalene triangle, second one isosceles triangle, and the third as equilateral triangle. So these are the three types of the triangle that are based on lengths of its sides. Let us see each of these one by one. So we are having the first one as scalene triangle, and it is a triangle in which the lengths of all the three sides are different. That means no two measures or no two sides are having the same lengths, or we can say all the three sides are having different lengths. For example, here we are having this triangle ABC. If we'll consider the length of BC as, for example, 6 centimeter, AC as 5 centimeter, and AB as 4 centimeter. So these three sides are having different lengths. So it's a scalene triangle. Now the second type is isosceles triangle, and isosceles triangle is a triangle in which the lengths of any two sides is same. That means if we are having a triangle and in this triangle, if the lengths of any two sides is same, just like here, we are having AB equal to AC. That means the lengths of these two sides is same. So we can say that this triangle is isosceles triangle. Also, there is a property related to isosceles triangle which says that the angles opposite to these equal sides are equal. So here our two sides AB and AC are equal and the angle opposite to side AB is angle C and the angle opposite to side AC is angle B. So according to the property of an isosceles triangle, these two angles are also equal. That means we can say angle B is equal to angle C. Now let's see the third type, which is equilateral triangle. And equilateral triangle is that triangle in which the lengths of all the three sides are same. So here in this triangle, all the three sides are equal to one another. That means AB is equal to BC and BC is also equal to AC. Or we can say all the three sides are equal to one another. And another property of this equilateral triangle is all the angles are equal to one another. That means angle A, angle B, angle C. They are equal to each other. So angle A is equal to angle B is equal to angle C. And all the angles are equal to 60-degree major. We will prove this later on in in our another tutorial how the measure of each angle in an equilateral triangle is 60 degree. So here we will remember this, that equilateral triangle is that triangle in which the lengths of all the three sides are same. Also, there is a property related to it that all the angles are equal and each measures 60 degrees. So these were three types of the triangle based on the lengths of its sides. Now we are having another group, and that is the types of triangle on the basis of measures of its angles. Since we are having the different types of the angles based on their measures, just like we are having acute angles, we are having obtuse angle, we are having right angle as well. So based on those measures of angles, our triangle, or we can say triangle, is classified into these three types: acute angled triangle, obtuse angled triangle, right angled triangle. Let's see these three as well one by one. So the first one is acute angled triangle, and it is that triangle in which all the interior angles are acute. That means all the angles of this triangle are acute. Just like we saw in equilateral triangle that all the angles are 60 degrees, so we can say equilateral triangle is always acute angled triangle. Similarly here, if we are having the measures as, for example, 50 degree, 60 degree, and here 70 degree. So all the three angles here in this triangle are acute. So we can simply say that this triangle is acute angled triangle. Now the second one is obtuse angled triangle, and we know that obtuse angle is that angle whose measure is greater than 90 but less than 180. So a triangle in which one angle is obtuse is an obtuse angled triangle. Remember it that only one angle can be obtuse. There can never be two obtuse angles in a triangle, because here if we'll consider this, for example, here it has 110 degrees. If we will suppose that another angle is also more than 90, for example 91, then if we will add these two, it will become 100, it will become 200 1 degrees. But it is not possible that sum of two angles of a triangle is more than 180, or because we know that the sum of all the angles of a triangle is 180, which we'll prove ahead in this tutorial. So it's simple that if in a triangle only one angle is obtuse, then the triangle is known as obtuse angled triangle, and the other two angles are always acute. Similarly, we have the third one as right angled triangle, and right angle is an angle whose measure is 90 degree. So here again in this triangle one angle is right angle, just like here we are having this angle, we are having this triangle ABC in which we have taken angle B as 90 degrees. So here our angle B is right angle, so this triangle ABC is a right angled triangle. So these were some types of the triangles based on lengths of its sides and then based on the measures of its angles. Now we will prove the angle sum property of a triangle, which we said that the sum of interior angles of a triangle is 180 degrees. So let's take a triangle, for example here, triangle ABC, in which the angles are angle A, angle B, angle C. That means we have to show that sum of angles of a triangle is 180. So angle A plus angle B plus angle C is 180 degrees. Let's try to prove it. So here we are having this triangle ABC in which angle A, angle B and angle C are its interior angles, and we have to show that sum of these three angles is equal to 180. In order to prove this, let's take a line. For example, here we will name this as PAQ. Let's take a line PAQ. So we will draw a line PAQ parallel to BC, and it is passing through A. Now let's name these angles that are formed here. For example, it is 1, it is 2, it's 3. Now this parallel line forms two more angles. Let's name this one as 4 and here as 5. We can see here this PAQ is parallel to BC, and if we'll consider AB as transversal, then angle 4 and angle 2, they are our alternate interior angles, and we read in one of our previous tutorials that when transversal intersects two parallel lines, then alternate interior angles are equal. So we can simply say, therefore, angle 4 is equal to angle 2 because alternate interior angles. Similarly, this PAQ is again parallel to BC, and if this time we will consider AC as transversal, then this angle 5 and angle 3, they form the linear pair of these, they form the alternate interior angle pairs, and alternate interior angles are equal when transversal intersects two parallel lines. So we can say angle 5 is equal to angle 3, again alternate interior angles. Now we can see here that angle 4 plus angle 1 plus angle 5, these three angles, angle 4 plus angle 1 plus angle 5, if we'll combine all these three angles together, they are forming a straight angle, and the measure of straight angle is 180 degrees. So together these three angles form a straight angle. So we'll give the reason here as straight angle, and the measure of straight angle is 180 degrees. So we can simply say that angle 4 plus angle 1 plus angle 5 is 180. But here we know that angle 4 is equal to angle 2. So in place of angle 4, we can write angle 2, then plus angle 1 plus, in place of angle 5, we can write angle 3 is equal to 180 degrees. Now let's write them in order. So angle 1 plus angle 2 plus angle 3 is equal to 180 degree, or we can write angle 1 is the interior angle of this triangle ABC. So in place of angle 1, we can write angle A plus angle B in place of angle 2, and angle C in place of angle 3 is equal to 180 degrees. So we proved here that sum of interior angles of a triangle is 180 degrees. Now let's see one more thing here, and that is exterior angle of a triangle. And it is if a side of a triangle is extended, for example, we are having a triangle here, and if we are extending one of its sides, just like here, BC is extended to point D, then the angle formed by the extended part, that means the angle formed by this extended part CD with adjacent side of this side, that means the adjacent side of the extended side, which is AC. So the angle formed by this extended part CD and adjacent side AC, this angle is known as exterior angle of the triangle. So here it is, our exterior angle. So again, if a side of a triangle is extended, then the angle formed by this extended part of the side and it is adjacent side, then it forms the exterior angle of a triangle. And the property related to exterior angle of a triangle states that the exterior angle of a triangle is always equal to the sum of two interior opposite angles. Just like here again, side BC is extended to point D, so it forms an exterior angle ACD. So this is our exterior angle, and it says that this exterior angle is equal to sum of two interior opposite angles. Let's name the angles of a triangle as, for example, here 1, this has 2, 3. Let's name this exterior angle as 4. So here angle 3 and angle 4, they are adjacent angles with each other as they are having a common vertex and a common arm. So the other two angles that are remaining here, just like angle 1 and angle 2, these are interior opposite angles to this exterior angle, angle 4. So we have to show that exterior angle, that is angle 4, is equal to sum of two interior opposite angles, which is angle 1 plus angle 2. So we have to prove that angle 4 is equal to angle 1 plus angle 2. Let's see it here. We know that from angle sum property of a triangle, we got it. Sum of angles of a triangle is 180 degrees, as we proved it. So we can write angle 1 plus angle 2 plus angle 3 is equal to 180 degrees. Let's write this as first. Also, here we can see that angle 3 and angle 4 forms a linear pair, and by the linear pair axiom we know that the sum of the linear pair of angles is 180 degrees. So we can say that angle 3 plus angle 4 is equal to 180 degrees. Let's write this as equation second. So from first and second, the right sides are same, so we can say the left sides will be equal as well. So from first and second, we get angle 1 plus angle 2 plus angle 3 is equal to angle 3 plus angle 4. Now here on both the sides we are having angle 3, so we can cancel out it. So we'll get angle 1 plus angle 2 is equal to angle 4, or we can write angle 4 is equal to angle 1 plus angle 2. So we proved here that exterior angle of a triangle is equal to sum of two interior opposite angles. So in our today's video tutorial, we did about triangle and then types of the triangle based on its length of sides, and then based on measures of its angles. And also we saw that sum of angles of a triangle is 180 degrees, and then we talked about exterior angle of a triangle, and then the property of exterior angle of a triangle says the exterior angle is equal to sum of two interior opposite angles. I hope you understood it. Thank you, and don't forget to subscribe the channel. Thank you again.